Imagine the 2D world, where it's impossible to go up or down. A 3D world implies that there are infinite planes adjacent to this 2D world. A 3D entity can see across a multitude of 2D planes, and move up and down with ease. If a 3D entity walked across the 2D world, 2D entities would only see a small 2D cross-section of the 3D entity at any given time. By comparison, imagine our 3D world, where you can move horizontally and vertically, but not in the 4D direction. A 4D world implies that there are infinite 3D spaces adjacent to our 3D world. We can only see one, the one we're in. If you could move 4D plus for a while, and go back 4D minus for the same while, you would end up in the same place. You didn't go up, down, left, right, forward, or backwards, you went across. To make it easier to understand, imagine you went across several 3D rooms similar to yours, but each of them is actually a different 3D space. A 4D entity is able to see across a multitude of 3D spaces, and move 4D plus and 4D minus with ease. In our example, a 4D entity could be in your room, sitting in the exact spot you are right now, but in a certain 4D plus distance. This entity can see where you are just by looking across, the same way we look at a 2D paper that is in a certain distance from us. A 4D entity has a body spread across multiple adjacent 3D spaces. If a 4D entity would stop by your room, you would only see a small 3D cross-section of the entity. As the entity walked across your room, the 3D cross-section would keep changing until it completely passes through our space. Imagine a 4D object. Let's say a 3D cross-section of this object is a cube, that you can rotate and view all sides. If you walk on a 4D plus direction, you would see that, as you walk, the cube might change its shape. If a 4D entity spins a rigid 4D object around, all 3D cross-sections of that object will be affected. 4D entities can see all points of a 3D object at once, just as 3D entities are able to see all the points of a 2D object at once. A 3D entity can think in 2 dimensions. If you imagine a cube, for example, you can only imagine it in 2D, like a picture, even if you imagine it with depth. A 2D entity would be able to see this projection, as long as we make it transparent. By analogy, anything that a 4D entity sees or imagines can be projected into 3D. If we make this projection transparent, we can see an entire 4D object as viewed by 4D entities, that is, only part of the actual 4D object. Imagine that the field of vision of a 3D entity, such as human beings, is a 2D rectangle. Let's say that the moment you look at something, this rectangle is initially empty. Your eyes then scan the entire 3D space in front of you, looking for information to fill up the rectangle. It will first detect objects that are close to you and take 2D snapshots of them, filling up certain areas of the rectangle. Once these areas are filled, no more information can be drawn on them, as there is nothing else between you and the things that were already drawn. Gradually the entire rectangle will fill up. Imagine, now, that the field of vision of a 4D entity is a 3D cube. This cube is initially empty. When the 4D entity looks across the 4th dimension, its eyes will scan the entire 4D interval in front of it looking for 3D shapes to fill the cube with. The first 3D information of 4D objects, which are closer in the 4D interval, will fill up certain parts of the cube first, and once this happens, no other shape will be able to occupy those parts. Eventually the cube will fill up entirely. 3D entities can paint only in 2D. We can take a piece of paper and draw any 2D form we want. However, we cannot draw real 3D shapes that can be rotated, using only a pencil. By analogy, 4D entities can paint only in 3D. A 4D entity would draw by pressing a pen-like device against a 4D object, or a 4D canvas. The pen would make visible marks on the 3D spaces adjacent to the first 3D space occupied by the 4D object. That means, once pressure is being applied with the pen-like device, the 4D entity might move its hands through the 3D space, up and down, left and right, forward and backwards to draw on top of the 4D object. Notice that this pressure is being applied across the fourth dimension. The analogy with our world is that when we draw something in a piece of paper, we actually draw above it, on the planes adjacent to it, and not inside the paper, and we are applying a force across the third dimension. It is known that 3D objects generate 2D shadows on 2D surfaces, and that 4D objects generate 3D shadows on 3D perimeters. A 4D device that generates light is able to spread that light not only across the 3D space, but also across the 4D direction. If there's a 4D object in the way of the light that is moving across the fourth dimension, certain 4D objects that are located behind it might not receive this light. Therefore, when the 3D volume of the 4D entity field of vision is filled up with the nearest 3D information, the brightness of the points of this 3D shape will vary in intensity. That's how 3D shadows are formed. And this concludes our basic analysis on the fourth spatial dimension. You are now ready to explore more advanced topics. Good luck!